Welcome back to Lesson 2. Here we're going to look at some more word problems involving multiple triangles. So example 1. A tower has an antenna attached to the top. Two guide wires connect the top of the tower and the top of the antenna to an anchor in the ground 590 meters from the base of the tower. If the tower is 600 meters tall, how tall is the antenna? So in this diagram here, we have the tower, and then on top of that, we have the antenna. So we're looking for the value of x. So to find out, what we can do is determine the combined height of the tower and the antenna, which I'll call y, and then subtract the height of the tower, 600 meters, and then we'll determine how tall the antenna is. Now, in order to do that, I need to know what this angle is. I know that this little bit here is 1 degree, but I don't know the value of this angle. So what I can do is use the small triangle to help determine theta. Now, what some people like to do when they're dealing with multiple right triangles is to separate the triangles. So you can draw the small triangle. This is 600 and this is 590, and this is theta. And then you can draw the larger triangle. I labeled this side y, and this is 590, and this angle here is what we're looking for. So now I'm going to use the small triangle to find theta. The 600 is opposite, the 590 is adjacent, so that means I'm going to use the tangent ratio. So now setting that up, I get tan theta equals 600 over 590. Now I have to do my inverse tan to determine what the angle is. And when I punch that in the calculator, I get 45 degrees. So now that means that the angle in the larger triangle is 46 degrees, 45 plus 1. So now y is opposite and 590 is adjacent, so again I'm going to use tan to find y. Tan of 46 equals y over 590. Now I cross multiply, and when I put that in the calculator, I get 611.0. So now I can find the antenna by subtracting the height of the tower from that. 611.0 minus 600 means the antenna is 11.0 meters tall. Now example 2. A hang glider soaring through the air spots two places where she can land. The angle of depression to the first landing spot is 25 degrees, and the angle of depression to the second spot is 11 degrees. If the hang glider is 120 feet in the air, how far apart are the two landing spots? So for this one, we're going to have to draw our own diagram. So I'm going to say that this is the hang glider, who is 120 feet in the air. Then over here is the first landing spot that she sees. Then a bit further away is the second landing spot. Now the angle of depression to the first spot is 25 degrees. So if I draw a horizontal line and then a line down to the first spot, this angle here is 25. And we learned that that angle is the same as this angle here, so I'm going to put it down in the right triangle I created. Now the angle of depression to the second spot, this angle here is 11 degrees, but that's the same as this one here. So now I'm looking to see how far apart the two landing spots are. So distance between here and here. Now you can go ahead again and break this into two separate triangles if you like. Now what I'm going to do to find the distance between 1 and 2 is first find x, then I'm going to find y, and then I'll subtract them, and then that will tell me how far apart the two landing spots are. So in order to find x, I'm going to focus on the small triangle here. The 120 feet is across from the angle, so that's opposite, and x is the adjacent. So we'll use tan. Tan 25 equals 120 over x. So I'm going to cross multiply. And then I'm going to divide. So my calculator, I'm going to put in 120 divided by tan 25. And when I do that, I get 257.3. Now if I look at the larger triangle, I see that 120 is still the opposite and y is the adjacent, so we'll use tan again. So similar to the one we just did, we are going to cross multiply and then divide. This time I'll divide 120 by tan 11, and this time I get 617.3. So now, to determine how far apart they are, I will subtract these two numbers. So the distance between the two landing spots is 617.3 minus 257.3, which is 360.0 feet.